A very warm welcome to Zurich in Switzerland. We're here at ABB headquarters celebrating World EV Day, World Electric Vehicle Day. It's a chance to mark the progress of a technology that's allowing communities, industries and consumers to move to a more sustainable, more environmentally friendly form of mobility. Now look, before we go any further, I want to give you a number just to remember, and that number is 900,000. Bear that in mind as I'm talking here, because in a moment we're going to be talking to one of our EV experts. But before that, I just want to bring you up to speed on the adoption of this technology. I remember when it first arrived, there was a lot of concern about this chicken and the egg problem. You need a certain number of cars before it's worth building the infrastructure. You need a certain amount of infrastructure before it's worth buying the cars. But now it seems we may be reaching that long-awaited tipping point. There's around 5 million of these battery electric vehicles on the roads worldwide, and that number's going up by about 1 million units every year. It is, of course, an area that's hugely dependent on technological advances in the cars and indeed in the charging infrastructure. And that is something we're seeing. I mean, here in Europe in 2020, of course, COVID quarantine restrictions have hit the vehicle industry hard. It's actually declined that market by about a third, but battery electric has boomed by more than 50%. So it's really bucking the trend. And when it comes to chargers, there's around 7 million of them around the world. Most of those are still in private hands. But that number I asked you to remember earlier, 900,000, those are the ones publicly available, and it's that number that's been boosted by around 60% compared to the previous year. So this is an area of huge development. I'm delighted to say I'm joined, waiting patiently here, is Adrian Wachholz, who's one of our ABB EV gurus here for the Swiss market. Adrian, do you think that tipping point has been reached in the adoption of this technology?
Yes, absolutely. So what we see on infrastructure side, many installations in the recent years, so the network is usable as of today. And also on the other side, car adoption and cars brought to market that have that technology, show and demonstrate that also that bid is ready. The technology is ready.
We're standing in front of one of these chargers here. Can you just talk us through what we're looking at? We hear of lots of different kinds of chargers. What are we seeing here?
What we have here is a little bit older ABB charger. It's a DC charger and much used, as you can also see. And basically has all the bits and pieces you need for EV adoption and to provide all the necessary charging needs, or to cover the charging needs of all users. So you have the different plugs for serving all vehicles that are around today. You have just a screen to interact with it, and just an RFID scanner in order to maybe facilitate payment.
You talked about different plugs. That was a concern with some people. Are there going to be too many standards? I also see there's a difference between some are marked DC, some are marked AC. What are these differences we're looking at?
So basically it comes back from a time when there were still different cars brought to market with all the different various standards. But now in the different regions there have been obviously an up or a quite good development to focus on one standard. In Europe and in Northern America, it's the CCS standard combined charging system, and that has one variant in Europe and one variant in the Americas for just to resemble or to reflect the differences in their grid, but otherwise it's very similar. And then we just have a difference between AC and DC charging here. Maybe we can dive into this at a later point.
Okay, well, let's give it a go then, shall we? Do you want to plug your car in and we'll see how it works?
Yeah. It's basically as easy as getting the car ready. So just opening it, open a charge port. Here you see you could plug in an AC charger at home or at the office, for example. And here is the DC port. This is what we'll use now. So we just take the appropriate plug here, and it's just a matter of plugging it in. And as at this location there's no authorization, we just need to hit the start button, and then the session will start.
Is this DC charging then, I see by the plug? What's the difference between AC charging and DC charging exactly?
Well, the fundamental difference is the way the energy is supplied to the car. All the charging you need to do also of mobile phones or all other devices, also a laptop, have basically the same underlying functionality. you have to know that the grid is always AC energy, and batteries always work with DC electricity. So what you need in order to get energy from the grid into your battery is a conversion at some point. With DC charging, for example, the conversion takes place outside of the car. With AC charging, the conversion takes place inside of the car, which brings natural restrictions.
So is it a bit like, I mean, obviously everyone nowadays is familiar with charging devices. Is this just like a huge mobile charger, or is the underlying technology fundamentally different in some way?
Well, I guess what is very similar is the way that it just converts AC into DC and supplies it to the vehicle or to the device with the right voltage at the right charging currents. That is the underlying similarity. What is vastly different, obviously, is the technology that is needed in order to bring those magnitudes to the device. So when you look at a mobile phone, the chargers are as big as a thumb. Here we have to supply much higher powers, which also have and create the need for much larger charging infrastructure. So here, for example, we have a 50 kilowatt DC charger that takes a little bit of space and weight.
You talk about the development of charging power. I mean, I know ABB's been in this space for around 10 years. What kind of development has there been in the technology in that time, and what are your hopes now for how it might develop in the future?
I guess there are two aspects, the purely technological aspect and then the user or usability aspect. When we look at technology 10 years back, 20 kilowatt DC charging was already considered the pinnacle of charging. So everyone was asking, will we ever need this kind of charging powers for EVs? Today we're charging at speeds of up to, or power levels of up to 350 kilowatts. So yes, there has been a huge development, which then is very important for the users because they can know and they know they can use even the highways, they can even travel long distances, and they're not hindered by their car, they're not hindered by the choose of or by the selected technology, because they can just dash out the vehicle, grab a drink, and when they're back after 8 minutes, they are full for the next 200 kilometers of traveling on the highway.
So what technologies do you look into when we're doing R&D on this stuff? Where are the areas where do you think this might keep moving forwards?
So I think what we've demonstrated nicely in the past, or ABB and ABB's team developing this, is to reach those power levels. So just achieving 350 kilowatts with one connector, that's amazing. There's been a lot of R&D efforts gone into just controlling those power levels and especially those currents. And what we see in the future, and this is directly aiming at the challenges that our customers and our customers' customers and the EV users will have in future, is just getting up the power density in order to make the best out of the restricted area and space you, for example, have in cities or in already populated areas. You do not always start in a green field. You also sometimes have to make do in the brown field where there's already installations, buildings, and electrical installation. So this is where we're going to go, higher power densities, and then also some smarter solutions in order to also make the best use of the electrical infrastructure that is already existing at the various different points where we want to do charging.
Of course, we're talking about cars, and I suppose when you say EV to most people, they tend to think of this kind of personal car, but there's a lot of other kinds of transportation involved in electric vehicles, right?
That is true. So we need to look at mobility as a whole. It's a holistic challenge for us, but as well as for society. So we need to make sure that the adoption of this clean technology can be achieved throughout the whole range of different means of transportation. So we have to look from the scooter, or maybe from the e-bike, that's not our focus, but from the scooter up to the car, and then beyond, for example, to trucks and buses. In all of these areas, whatever we do creates benefits for the cities and for the locations adopting this technology.
It must be quite a challenge for cities as well, though, if there's a huge number of these vehicles needing that kind of power. I mean, is there legislation that helps that? Are there initiatives? What's your assessment of the landscape out there?
Hmm. Of course, there are huge challenges to the cities, especially to the distribution net or grid operators, because you will see that the power that is needed to operate these chargers and to operate EVs in a city is immense. So it can be very, very huge. If we look at, for example, a 50 kilowatt charger and compare it to the grid connection of a single family home, you'll see that you could supply 2 homes with a grid connection of that charger, for example, in Switzerland. If we look at a 350 kilowatt charger, that is the 7-fold that number. And if you see what's happening at charge parks, where you want to provide a high throughput and a high level of service for the EV drivers, even in rush hour, etc., this grid connection would be even larger, right? So what is needed are intelligent solutions, digital solutions that will make the best of the electrical installation that is in place today, in order to limit investments that would be needed, for example, in order to put copper into the ground, and other solutions that are needed to bring more power to different locations.
And then I suppose we get into smart city territory. I mean, I'm wondering, electrification we see is quite a trend across lots of industries at the moment. And I wonder how well it connects with other mega trends that we see. I'm thinking of things like digitalization, like moves towards autonomy. Do electric vehicles connect on that kind of level as well?
Very much so. It's actually quite vital to the whole industry. So on the distribution side, for example, I just said we don't want to put more copper into the ground. What we want is digital solutions that are controlling the loads in a smart way. Make use of what you have today in terms of infrastructure, but control it with smart algorithms and smart solutions that are controlling the power. Energy we have, it's the power that needs to be at the right point, at the right time, basically.
And do you think this will lead to a reconception of how filling your car up works? I mean, at the minute we think of it as something you stop to do during a journey. Will that change? Do you think that will go through a conceptual shift?
Totally. Well, you see with EVs, they look like cars and they drive like cars that we know, but it'll change the way we live with them. So instead of refueling and going actively to the gas station and filling up the car when the gas price drops just at the right moment, so you can keep track of it, you rather charge whenever you have the opportunity to do so. So you'll charge at home overnight, you'll charge at the office during your working time, you'll charge during your shopping, your sports, etc. So what you will see is that actually moving to an EV is much more comfortable, is much more user-friendly than going with an old internal combustion engine car, where you have, yes, maybe 600 kilometers of autonomy, but you actively have to go and look and refuel all the time.
Bright things ahead. Thank you very much for your time, Adrian. Look, if you're interested in this stuff, please do have a look at all of our other material on our YouTube channel. We'll be following all kinds of transport and mobility stories throughout September and periodically. Please have a look at our Twitter, at our Instagram, at our LinkedIn, at our YouTube. I'm sure there's one I'm forgetting, but keep an eye on our social media and we'll keep you up to date on all the latest developments in those areas. But for now, thanks very much for bearing with us. From Adrian and myself, it's goodbye.